Hello, welcome to Simultaneous Equations with two variables. Here's some of the examples. I'm sure you've seen these before at least. Unless you're learning maths entirely through my course, which, good luck. But simultaneous equations, very famous, one of the early things you learn how to do in a later secondary level maths course. Okay, now here's the problem. There's two ways to do simultaneous equations. One is taught by a lot of teachers. It is all about matching up the coefficients. Like this one here would work. You could add these together and the y's would cancel. On this one you might multiply the top row by 1, sometimes they say to do both, but obviously 1 doesn't do anything. Multiply the bottom row by, say, 2. Make these match and take the equations away. This one would be a mess. You'd have to rearrange it first, but you could do this. Now I don't want to teach it more than what I just did. I am going to teach I'm not 100% sure if it's called this, a substitution method. It will work for these questions, sometimes a little longer, sometimes a little shorter. It will also though work for more complicated questions. And it's more the idea of this one, the one I'm going to teach, I feel is much more useful through all of maths. The other way to match them up, take them away, solve it, it's very formulaic. It's like a algorithm, and it's useful if you are going to have to solve a lot of these questions. It might be how we would teach a computer to solve a lot of these questions. But I expect a maths student, if you want to be good at maths, you should be thinking how to solve a question. You should be looking at it, figuring out what do I need to do, how do I solve it. And this substitution method will be used in a lot of other questions other than these type. So that's what I'd like to teach. So we'll go through each of these. I recommend you pause the video and have a go at each question before I do it. X plus y equals 10, x minus y equals 4. Let me number these, 1 and 2. You don't have to do this. It's really just for helping to teach someone. It might be useful. Okay, so my method, not my method, somebody else invented it, I'm sure, revolves around taking one equation. So you think of each of these equations as a piece of information. Both equations are not enough on their own. I cannot solve an equation with two unknowns. It's too much for me. It's too much information. I cannot solve the other equation with two unknowns. But what I can do is I can take one of the equations and change how it looks so it becomes x equals or y equals. Let me write that like this. Give myself a bit more room here. Y equals. Now I'll explain why I'm doing that in a moment. But for now, let's take the top row. Let's take 1 and get y is equal to 10 minus x. Take x from both sides. Now the reason I'm doing this is I've now changed the first equation to the form of one of the unknowns. So there's two things you don't know in it. But now I have one of them equal to in the form of the other. So it's equal to something x. Like some number of x's, some number of numbers. This is extremely useful and powerful. This idea will be used in many different ways in maths. Because now let's write the second one again. Let's write x minus y equals 4. Now I skipped the y because I now know a different way to write y. If I told you y is equal to 1, you'd write 1. If I told you y is equal to 10 minus x, write 10 minus x. I might be a little small. Let me write that again. So it's the second equation goes to x minus 10 minus x, because that is now y. I do not need to write y if I could write this. Now, obviously y is a little shorter, so I might write y sometimes, but no, I can see a good reason to do this. And that good reason is I now have one equation with one variable. Only x is unknown in this equation. That's something I can solve. That's something we've already done. So x minus 10 minus, this, remember this is a little minus 1. Minus multiplied by 10 is minus 10. Minus multiplied by minus x is plus x equals 4. 2x, add the x's together, is equal to 14. Add 10 to both sides. X is equal to 7. Divide both sides by 2. We're not finished. Please do not finish the question like that. So many students do that, and they're throwing away, if it was an exam, they're throwing away marks. If it was real life and you wanted information, well, you haven't got it. You haven't got enough. Actually, in real life, you might have only wanted x, so you could stop. But usually you want both the variables. I caught myself there because real life would be more common to just want one. Whereas exams, they always ask you for both. But still, you're probably more interested in an exam at the moment if you're watching this level. So you would be asked to find both x and y. You found x. You still need y. But luckily, and here's another, this method speeds up something. We can use this equation, let's call it 3. Y equals 10 minus x. I already know what y equals. Y is equal to 10 minus 7. Y is equal to 3. And we're done. That is the substitution method. I'm going to do this another 2 times, so we'll see it again. And in fact, the next video, we'll be looking at 3 variables, something much harder, not something everyone needs to learn. But I'll use this method again. Later, a few videos from now, I will use quadratic equations as one of these 2. I will use this. In fact, you have to use this method in that case. Okay, one last thing before I finish. Test your answer. Here's your answers and test them. X equals 7, y equals 3. 7 plus 3 is 10. Good. 7 minus 3 is 4. Good. Okay, we're right. We are correct. It's good to test. It's always good to test. Right, let's have a look at part 2. Again, I'd love you to pause the video and attempt this at your own pace. Take 30 minutes, take 30 hours. That'd be a long time, but still, take whatever time you want and come back to me. Okay, once again, I'll get x equals or y equals. This time I'll just choose x equals. Mainly because the last time I chose y. Equation 1 and 2. So x equals. I'll look for x equals. Now, one more hint. You always use the simpler equation first. Take the simple equation and get that to fix the hard equation. It's one way I think of it. The first example we did, they were both simple. But in this case, if I wanted y equals, I would use 2, and I would just get y is equal to 5 minus x. I'm sorry, I said I was going to get x equals, didn't I? X is equal to 5 minus y. I just used 2 here. I took y from both sides. Y from both sides. Okay, so we call that 3. I think we'll have more than enough room to fit this in. The last one's going to be pretty big and messy. Okay, so now I'm going to write equation 1, 2x plus 3y is equal to 12. I'm just writing equation 1 again, but instead of x, I have a much more useful thing to write. 5 minus y. That is equal to x. Do not use x if something else is better and it's equal. If you know what x is equal, you can always write that instead of it. If x equals 5, put 5 in. If x equals q, you can put q in if you want. If x equals 5 minus y, you can put in 5 minus y. By the way, I made q up there. There's no q anywhere. Alright, let's clean this up. 10 minus 2y plus 2y is equal to 12. That is, that's just y left there. Plus 10, I guess I could write. I have lots of room, so I thought I'd add that in. Y is equal to 2. I took 10 from both sides. Please do not forget, I do not want y on its own. I want x as well. X is is equal to 5 minus y. X is equal to 5 minus y. I'm not going to write y. I know what y is. It's 2. X is equal to 3. Let's test our answer once more. Go back to the first thing. Where we got? Y is 2. 3 and 2. Okay. That's 6 plus 6 is 12. Good. Where are we? 3 plus 2 is 5. Perfect. We are correct. We've got it right again. I don't always get it right. Be warned. Usually I'll check my answer though and take that out of the video. Alright, let's look at part 3. We might need a bit of room. I know there's a shine on the screen. Hopefully it doesn't hit there. I always put the title underneath the shine. I've rearranged the camera and all. I can't get rid of it. I'd have to put the camera all the way up in the roof to get rid of it. Right, where am I? Okay, 2x plus 7y is equal to 3. Once again, please pause the video, especially this question. You might have solved the other questions using a different way that you already knew. Whereas this one might look a little messier. It can still be done. You just have to rearrange it to make it look like these two, and you can still use the different method if you want, but not my method. You don't need to for my method. You just get x equals or y equals. I'm going to get y equals because I'm going to look at the first one. Let's put in 1 and 2 here. I'm going to look at the first equation and think to myself, well, that's easier than the second one, so I'll get something from that. I'll get some information from that one, and I'll get y equals, just because y, it would make more pluses, I think. I don't know. Doesn't really matter. Maybe x equals would leave a 2 in the denominator. You know what? Let's get x equals. Maybe that'd be a bit easier. 2x equals 3 minus 7y. This is from 1. X is equal to 3 minus 7y divided by 2. Okay, we've got x equals. Let's call this 3. Hope I have enough room here. Now I'm just going to write the second equation again. This big mess, I'm going to have a bit of trouble. X, I'm going to write x. Remember, that is x now. X equals this. I know it's the same thing. I don't have to write x when I can write this. Plus y is equal to x divided by 2 minus 2y plus 1, all divided by 2. Okay, this is a big mess of an equation, so it's going to test our ability to move things around. These 2's, I don't like them. Now later on we might get confident enough to... I think we're confident enough now. Oh, it doesn't go over this y, I'm sorry. Let me start that again. So, yeah, we need to solve out this equation. So, how about if I multiply everything by 2? That's going to destroy something. If you're not sure what, that's fine. I can see what it's going to destroy. But hopefully you can see it's certainly going to do some work. Let's be careful how we do it. Multiply everything by 2. Here's 1. What would we call this? Term. Here's one term, another term. This is one big term at the moment because it's all over that 2. Okay, multiplied by 2, we get 3 minus 7y. The 2 and the 2 will divide to become 1. Plus 2y is equal to 3 minus 7y over 2 minus 2y plus 1. The 2 multiplied by this 2 and created a 1. Destroyed it. Okay, I'm still not done. I'd like to get rid of this 2. When you get a bit better, you might have been able to look ahead and multiply everything by 4. But let's multiply by 2 again. 6 minus 14y plus 4y is equal to 3 minus 7y, 2 by 2. It's gone, minus 4y plus 2. Multiply everything by 2. Okay, let's clean some of this up. 6 minus 10y is equal to 3 and the 2 is 5. Minus 7y and minus 4y is minus 11y. Okay, let's destroy this term here. Let's add plus 11 to both sides, because I can see into the future and see that that's going to give me a plus y in my answer. It'll just save me another line. And also we will take 6 from both sides. Okay, so minus 10y plus 11y is equal to 5 minus 6. That's y is equal to minus 1. Now, I apologize. I know this end of the board gets a little smaller for people. Hopefully this will be still seeable. Minus 1, we're not finished. We still need x. But that's okay. Look ahead. Look back. There's a nice easy equation, number 3. That will tell me x equals 3 minus 7 multiplied by minus 1 divided by 2, which is equal to minus 7 plus 7, 10 divided by 2, which is equal to 5. Oh, bit of a curve in the screen there. X is equal to 5. Just barely made it in on the screen. Let's test our answer. It's a bit of a mess. Maybe use your calculator to help you. But x is 5 and y is minus 1. That's 10. Minus 7 is 3. Good. 5 minus 1 is 4. 4 on the left. On the right, we get 5 minus 2. That's 7. Plus 1 is 8. 8 divided by 2 is 4. Good. 4 equals 4. Brilliant. These numbers are in fact correct. Right, so that's my method. That's my substitution method. Take one equation that has too much information, rearrange it so it looks like y equals in this case. X equals in this one. And x equals in this case. Use that new found information. It's not really new, it's just rearranged, and put it into the other equation. What that will do is it will destroy one of the letters for you. X equals this. When you put it in, you've destroyed the x's. Only y is left. Probably easier to see on one of the smaller ones. Okay, if you have any questions, please put them in the comments. If you'd like to see more of these, you should be able to search simultaneous equations online. You should be able to find a load of these to practice with. I must get around to making some worksheets for each video.